This is a quick video on arithmetic sequences. So I have three different number patterns up here. This should look like a number pattern, this middle one, and this one should look like some kind of number pattern, whether you could identify it or not. The first one probably doesn't look like a number pattern. Now what I've done is I've written the number of terms that each one of these is. This is the first term, this is the second term, this is the third term. So we call them a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Now, if you look at this middle pattern, these are all perfect squares. And so this is 1 squared, 2 squared, 3 squared, 4 squared, or in other words, we could say n squared. That would be one way to write the nth term for that pattern right there. This one might be a little harder to write if you're trying to write a pattern, a formula for the nth term, but you can see that each numerator is one less than its denominator. And each fraction, the numerators go up by 1 and the denominators go up by 1. So really, this is my first term. Well, I'm taking 1 and I'm adding 1 to get 2. Taking 1 and I'm adding 2 to get 3. And I'm doing that all across, so we can say this pattern is n plus 1, for example, 3 plus 1 is 4, and 3 plus 2 is 5. So n plus 1 over n plus 2. So that might be a way to write the nth term for this pattern. But the first one is what I really want to talk about, because the first one is actually an arithmetic sequence. An arithmetic sequence is a pattern of numbers where each number, you just add the same number to the previous number to get the next number. So in other words, for each one of these, I'm adding the same number each time to get the next number. If I take any two of these numbers and subtract them, like 25 minus 18, well, 25 minus 18 is 7. That's the same thing I get if I start with 39 minus its neighbor, which is 32. I get 7. So if I take any of those two numbers side by side and I subtract them, I'm going to get the same number. This number right here is called our common difference. So an arithmetic pattern has a common difference. The same numbers being added or subtracted to get the next number each time. If I want to write a pattern for the nth term of an arithmetic sequence, I would start with the first term, okay, a sub 1, which in this case is 11. And let's say I wanted to write a formula that would give me 39 for the fifth term. Well, then I would start with 11 and I would add this common difference so many times. Well, how many times would I add that difference to get up to the fifth term? Well, to get up to the fifth term, I add that common difference 1, 2, 3, 4 times. So it's the fifth term, but I add it in minus 1 times. And this is the way we get a pattern for the nth term in an arithmetic sequence. So for this one, if I were writing the nth term, I would say it's the first term plus 7 times n minus 1. When I simplify that, get 11 plus 7n minus 7, and that's going to be 4 plus 7n. If you'll notice, it's a linear pattern. Y equals mx plus b. It's linear. Arithmetic sequences always have a linear pattern. That's how you know that you have an arithmetic sequence. So when you look at a sequence of numbers, you can identify whether it's linear or not, either by looking at the nth term, the formula for the nth term, and seeing if it's linear, or you can just see if there's a common difference. If you've got a list of terms, you can see that there's a common difference. Now, let's suppose that I know two numbers in a pattern, and I know that that pattern is an arithmetic pattern. Let's say that I know, so suppose I know that a sub 8 is 24 and a sub 20 is negative 60. And I want to come up with an nth term, a pattern for the nth term in that sequence. Well, I need to know my first term and I need to know my common difference. Well, the difference is easy to get because all you do is you take, for example, here, if I took these two numbers and I subtracted them, and then I divided by the number of differences I had between them, I would get that. I would be able to get that pattern. So in other words, I've got 5 terms. I've got my 5th term and my 1st term, and if I subtract 5 and 1, I get 4. So I know there are 4 D's between those. So here I have my 20th term and my 8th term, and if I divide that by 20 minus 8, that tells me how many D's I have between the 8th term and the 20th term. And so this is going to help me know what D actually is. All right, so my 20th term is negative 60. This one's 24. And 20 minus 8 is 12. So I've got negative 84 over 12, and that's negative 7. That's my D. This is how you get D when you have 2 terms in the middle of the sequence. Now I still need to get a sub 1. To get a sub 1, I pick either one of these. So I'm going to pick a sub 8. And a sub 8 is supposed to equal a sub 1 plus my D times n. Well, n is 8 this time. 8 minus 1. So I found D right there. And I know a sub 8. A sub 8 is 24. So 24 equals a sub 1 plus negative 7. And then 8 minus 1 is 7. So this is 24 equals a sub 1 minus 49. When I add 49 over here, then I get that a sub 1 is 73. Now I have enough information to write my nth term. A sub n equals 73 minus 7, because D is negative 7, times n minus 1. All right, well, that's 73 minus 7n plus 7. That's going to be 80 minus 7n. You see, it's a linear pattern. All right, well, let's talk about the sum of an arithmetic sequence. So if you want to write the sum, the formula for the sum of an arithmetic sequence, we can do that as well. All right, so I'm going to erase this and put a different pattern up here. So here's another arithmetic pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I wanted to add those up, the easy way to do that would be to take these two and add them, and I get 10. And then these two, and I add them, and I get another 10. And then these two, I add those and get 10. And then these two, I get another 10, and then I have a 5 left over. So basically, out of those 9 terms, I have 4 10s plus 5, that middle term, and 5 is half of a 10. So I have 4 1/2 10s. Well, let's look at that then. This is true for any arithmetic sequence. So the sum of n terms can be found by taking the first term and the last term. Now that's what a sub n is. If you want the sum of the first 10 terms, n is 10. Sum of the first 20 terms, n is 20. So this is my first term, my last term. And if I take the number of terms, in this case it was 9, if I divide 9 by 2, I get 4 1/2. So you take the number of terms, divide it by 2, and this is how you find the sum for an arithmetic sequence. Now, let's suppose you have it written using this sum terminology right here, this sum symbol. So, for example, n equals 1 to 20. Let's say the pattern 4n. 4n is linear. Therefore, I know this is an arithmetic pattern, and I can use this formula to get that sum. What I would do is I would write S20, sum of the first 20 terms, and that's going to be n. So n is 20, because 20 minus 1 is 19. So there are 19 D's between the first term and the last term. But don't forget, that 19 D's means that I have 20 terms. So I have 20 over 2. The first term is when n is 1, so that's 4. The last term is when n is 20, and so that's 4 times 20. So I have 20 over 2, and then 4 plus 80, and then that would be 10 times 84, which is 840. Now, let's suppose, though, that our sum were written this way. N equals 3 to 17. How many terms is that? Well, it's not the sum of the first 20 terms, so I wouldn't identify it like that. Well, let's put my 4 in right here. But what I would do is I would say my sum equals. So I'm not going to put a number down here, okay, because that could be misleading. But I've got to figure out how many terms I have. Well, remember, it's 17 minus 3. That tells me how many D's I have. 17 minus 3 is 14, plus 1 extra for my first term. So 14 plus 1 is 15. So I would have 15 over 2 because I've got 15 terms. But now my first term is not when n is 1, it's when n is 3. 4 times 3. And my last term is when n is 17. So I have 15 over 2 times 12 plus 68. And 12 plus 68 is 80. So I have 15 over 2 times 80. That gives me 40. So that gives me 600. And that's how you find the sum when you've got sort of an oddball set of terms there.